Okay, Salaam Chem Theory. So just a recap of what we did in class. When we look at the table of selected standard electrode potentials, or the page 7 in your data booklet, all those voltage values are relative. What they mean, and when I say relative, it means that they're in reference to something being zero. There isn't a true zero when it comes to potential energy, whether it's electric potential or gravitational. There is no zero. There's something that approaches zero, but zero is just an arbitrary number that we assign something and compare everything else to it. And so on page 7 in the data booklet, that zero is hydrogen. And so we're comparing everything else to hydrogen, whether it's a metal, non-metal. We compare its ability to reduce or to steal an electron to the hydrogen atom, and we assign that zero. Now, what happens if you're in a lab and hydrogen isn't readily accessible? And I need to know the conductivities for energies in my reaction in order to yield something better. And I don't have hydrogen available to compare it to. Then I would set a new standard to zero. Meaning I would set something else to zero and compare everything else to that. The thing is, when you change the cell reference from hydrogen to something else, all the values that we have in the data booklet would also change as well. So to kind of give you a better idea, let's take a look at the data booklet. When you go and you find hydrogen, and we follow along, we see that it has a reduction potential of 0. And then we got all the elements that reduce less than hydrogen would, so have less of a chance of gaining electrons, which that's why they carry negative values. And then we have a bunch of elements or compounds that have a greater chance at gaining electrons, hence have a positive potential. Now imagine I take that 0 and I bring that 0 down to here, because this is just an arbitrary 0. We're just comparing things to hydrogen, but it's not 0 by itself. And imagine I did something like, I don't know, let's say I changed cadmium to the reference. I have a lab and I have a bunch of cadmium, and so it makes a lot more sense to make that the new reference. So instead of writing negative 0.4, I would scratch that out and put 0. Now the thing is, if I take something like bromine, which is 1.7, well, that was 1.7 from here. But then if I go from here all the way down to my new reference, that difference is a lot bigger than the original 1.7. So let's say we look at this question which says, what's the reduction potential, which is the voltage, of copper solid if nickel solid was assigned the value of 0? So now hydrogen is no longer the reference. We're comparing the value of copper to the value of nickel and getting a voltage from there. Well, there's two ways you could do it. You can think about it visually, which is copper is 0.34 with this much distance when hydrogen is the reference. Now, if nickel becomes the reference, and it originally has a value of negative 0.26 volts, and I assigned that 0, well, that is a lot bigger than that. And so the voltage of copper is going to increase. Now, some people can do this in their head, right? And then they would just go, well, the difference between 0.34 and 0.26, it would be whatever it is, and they could just do it in their heads and they would get the value. Other people might find it easier to use the formula. Either way, it's going to work fine. Now, if I'm using the formula, I would say that the new value of copper is going to equal to the old value minus the new reference. So the new value of copper is going to equal to the old value of copper, which is this over here, the 0.34. So I would plug that into the brackets. And then minus the new reference. Now we're assigning the new reference 0, but really its value was what? Negative 0.26. So I'm going to plug in what that new reference value would be, and the difference between that is going to be our answer. And when I do calculate that, I end up with, that turns to positive, plus 0.60 volts. Visually that this would be plus 0.60, or you like to use the formula. If you find both helps, whatever you can do for yourself, it's totally fine. But let's do another example. Okay, so for our second question, same process here. What's the reduction potential of chlorine gas if silver bromide was the new standard reference? So when we say the new standard reference, that is equivalent to saying assigned a value of 0.00. So you're moving the hydrogen reference. So here, I'm going to do the same thing now. What you do have to know is what is silver bromide. So silver bromide is AgBr solid. And you can find that in your data booklet. So I'm going to do the same thing. Your chlorine reduction potential is going to be positive 1.36 if it's from here to here, which is the hydrogen reference. But now we're moving that down. Okay, or I would say even we moved it up. I kind of did it backwards here, but technically this would be below because it has a lesser value. So we would go 2H plus 2E. I'm going to write it down here. And then that'll be H2 gas. And that has a value of 0.00 volts. So this 1.36 is really with reference to hydrogen. Now we're going to make it actually smaller. In the first question, the value increased. This is probably going to decrease. So again, you can visually think about it. What's the difference between 1.36 and 0.07? Right? And you could say, okay, 1.29. Or you can use the formula, once again, which is new value equals old value of the chlorine gas minus the new reference. And so plugging in our old value with hydrogen as the reference is this, the 1.36. And the new reference, which means I would actually pretend that this is 0 volts, but I would put in the old value, is positive 0.07 volts. And that should give us 1.29 positive. So the value went down. So it's not about whether it goes up or down. It's just that the value changes based on however you change the reference. So this process always repeats. If you want to use, once again, the formula or the diagram or both to understand it, they both will get you the same way. And inshallah, this helps.